What other IT jobs are out there? I don't want to be a programmer. I get this question 2 to 3 times a year, mostly from college students doing an internship. They're usually studying management information system or computer science. They're finishing up their core classes, working on their final projects, and getting ready to graduate. But no one seems to be telling them what other IT jobs are out there besides programming. And they really don't want to be programming 8 hours a day. I get it. It isn't for everyone. We often think of technology as hardware and software. Naturally, the only job we can think of are 1. Building the hardware. That sounds like a job for engineers. And 2. Writing the software. That sounds like a job for programmers. And that will be it. It is no wonder that the title question exists out there. To understand what other IT jobs there are, it is necessary to move away from this technology-only perspective. This new perspective has additional dimensions. Obviously, we still need the hardware and the software. The second dimension is people, the users of the technologies. The third dimension is process, the steps the people follow to use the technologies. People, process, and technology together forms a solution. And so we call this way of looking at things the solution perspective. Outside of a solution is the fourth dimension, time. There's a time before a solution came into existence. There is a time when it was coming into existence. There is a time when it is useful and it's being used. And lastly, there is a time when it ceases to be useful and reached its end of life. We can also call this dimension the life cycle of a solution. It should be fairly intuitive to associate the work being done in these phases. Before a solution, we can learn about how things were done, with what, and by whom. This is the basis to which we compare the new solution to in order to determine success. During the birth of a solution is when we see the initial design-build activities, along the way hopefully validating that it is indeed better than the past. During the life of a solution is when we see the solution being used by users, being operated on by those who administered it, being supported by support personnel, and being maintained by all manners of IT people on an ongoing basis. To extend the life and usefulness of a solution, there are always upgrades and enhancements. They usually require additional design-build work. Software and hardware might need to be upgraded, people might need to be retrained, and processes might need to be updated. When a solution reaches its end of life, there are work specific to information archival, data destruction, and resource recycling. This solution perspective will serve as the backdrop in our learning about the IT jobs out there. To make it easier to illustrate, we will need an example. Let's say ABC Bank wants to make depositing a check easier for its account holders. There are 2 existing solutions already. Account holders can make the deposit in the bank, or they can do it at the ATMs. ABC wants a new solution. They want the account holders to be able to deposit a check using their smartphones. Here, a person with a technology-only perspective might say something like, "What's so hard about that? Just get someone to build an app, take pictures of the check, cross the T, dot the I's, and send it to the bank. Done." This is where everyone screams. Let's switch to a solution perspective so we can better visualize this. Remember, a solution is people, process, and technology. An account holder, let's call her Aunt May, has a smartphone. She wants to deposit a check. First thing she will need is the app. Depending on whether she has an iPhone or an Android phone, she'll have to go to the App Store or the Play Store, find the ABC Bank app, and install it. Once done, she starts the app. She logs in for the first time, enter her login, password, and do whatever the app tells her to do to verify herself. Now she can hit the deposit button. Select which account to deposit to, enters the amount, take a picture of the front of the check, confirms it, grab a pen and endorse the back of the check, take a picture of the back of the check, confirms that, confirm all the informations, and hit submit. The app says done, and May closes the app. That is the solution's narrative. Let's imagine the first meeting inside ABC Bank where they discuss this new solution. After listening to the narrative, the mainframe bank application team, the website team, and the ATM team all look at each other and ask, who's going to build that? We don't have a relationship with Apple or Google. Who's going to be responsible for those contracts and manage the app releases? If the customer run into issues, who are they going to call? The customer service manager jumped in. Don't look at us. Our call center doesn't have the staff or the training to support mobile device and mobile apps. You know how many smartphones there are out there? The IT people start talking about Samsung phones and LG phones. The deposit manager quietly raised her hand and said, wait a minute. Without the physical checks, how do we verify the amounts? My team verify every single deposit against the check currently. We need the checks. Before anyone can answer, the security manager raised his hand and said, I'm not comfortable with this app that we don't have. How do we secure it? And where does this login come from? The same as the website? The website manager said, the mobile app cannot use the website's login. If it is compromised, the website will be compromised too. I don't want to deal with that. This might be a little bit exaggerated, but fears of the unknown often drive the discussion on new solutions. This is why we introduced the first non-programmer job. Here we recognize computer system analysts. Sometimes companies also call them different names such as business analysts, system analysts, business system analysts. In fact, just a few days ago, for the first time, I saw a job posting for system business analyst. Never heard that one before in 30 years of my career. Here, I feel we need to take a slight detour before anyone goes crazy about the job titles. In the United States, there are over 150 million jobs. A job is what the work is, but companies are free to give them whatever job titles they want. There are over 12,000 job titles out there at any given time, and new ones are being created every day, even if the jobs themselves are not changing. In the late 70s, the US government recognized a need to have a proper way to categorize these jobs, independent of what they're called, so that the US labor market can be properly analyzed and reported on. You know those reports you hear in the news about unemployment rates, which sector is growing faster, which one is shrinking, and so on? This is part of that work. Under the Executive Office of the President of the United States, a collaboration committee was formed between Department of Labor, Department of Commerce, Defense, Education, National Science Foundation, and many more. A few years later, in 1980, they first published the Standardized Occupational Classification System, SOC in short, which classified all the jobs in the United States into occupations independent of job titles. Over the years, the SOC Revision Policy Committee, the SOC RPC, have grown to include 15 agencies and work constantly to update this list. The most recent revision of the SOC manual was published in 2018. It contains 23 major occupational groups, which breaks down into 98 minor groups, 459 broad occupations, and 867 detailed occupations. If you're part of the US workforce and get paid for doing the work you do, you are in one of these occupations. In this video, instead of choosing what one company calls a job over another, or choosing what I personally prefer the job titles to be, I've decided to use the standardized list as reference. Whenever possible, I will also include the SOC number so everyone can look it up and minimize confusion. I have also included a link to the SOC manual in the description of this video. A big thank you to the US Bureau of Labor Statistics for helping me understand how to use this. Back to the subject. The first non-programmer job we recognize is Computer System Analysts, SOC code 15-1211. Computer System Analyst has a few key responsibilities. They analyze issues related to a solution, bring people together to discuss concerns, document their needs and wants, assist the responsible and accountable parties in resolving any conflicts, and record who made which decisions. The most common output of CSAs is a set of requirement documents which describe a solution and serve to drive the detailed design of both the technologies and the processes. On occasion, CSAs will also assist different operating units in designing and redesigning the relevant processes needed to implement the solution. In our example, how the deposit team validate checks deposited by the smartphone would likely require a new process. Both the need and the engineered process would be documented by the CSAs. Remember the chaotic meeting at the ABC Bank? The CSAs assigned to this project would have jumped in halfway through the meeting, reassured everyone that their needs and wants will be documented. All the decisions that need to be made will be brought forth to those who are authorized to make them. The outcome of this type of meeting would be a plan of attack and a series of next steps instead of anxious parties not having any idea what's to come next. CSAs often serve as a trusted party, ensuring no concerns goes unresolved. To get to the technical jobs, let's take our example deeper into the technical realm. Aunt May has a smartphone. For completeness' sake, let's also be clear that the phone has its own operating system. An iPhone would have iOS, a Samsung would have a Google Android. On top of it is where the ABC Bank mobile app will sit. Of course, we want the app to connect to the bank. Ultimately, our goal is to be able to deposit a check. Depending on which carrier Aunt May chooses, that will give the app access to the internet. ABC Bank probably has its own data center, and it is connected to the internet via an internet service provider. Any data traffic coming into the bank will first hit some sort of firewall and security implements. Once it has been validated to be legitimate, the mobile app will be talking to the corresponding mobile application services software. Like our software, it will be running in an operating system on top of a server. The mobile app will probably has its own database sitting on top of a database engine on a server. But the mobile app is not the main bank application. From a control standpoint, it's probably safer to design it to let the main banking software execute the actual bank transaction, like depositing a check. The banking app, just like any large-scale multi-user software, will have an application layer and a database layer. In fact, in the bank branches, the teller application is probably connected to this. The same architecture is probably used for ATM operations, whether the ATMs are inside a bank branch or stand alone in a shopping mall or theaters. The bank's website is probably set up the same way. The next set of IT jobs we want to identify are the IT architects. Today, IT architects are recognized within their respective IT domains. In the domain of networking, we have computer network architects. In the domain of database, we have database architects. Software application architecture is designed by software developers, and web architecture is designed by web developers. Architects analyze all requirements and constraints, reconcile and resolve those that are conflicting, balance performance versus cost, negotiate with other stakeholders to optimize technical designs, then produce technology blueprints and specification for the rest of IT domains. The picture you saw would be jointly put together by IT architects. We're also beginning to see a couple of newer ones in the job market. cloud architects who are specialized in designs that integrate cloud technologies and on-premise technologies, and enterprise technology architects who are versed in multiple IT domains. From the design of our solution, we also see other IT jobs. The connections within an organization, whether it is a single physical location or multiple locations, are all part of a network. In recent years, the concept of network expanded even more to include outsourced cloud technologies. Here we recognize the next IT occupation, network administrators. SOC classified occupation as network and computer system administrators. Network administrators build, maintain, and support a network. In the absence of network architects, administrators will also take on the role to design networks. This includes all the networking hardware such as cabling, racks, switches, routers, and all manners of data communication equipment, and their corresponding configurations. If the company outsources these work, the network administrators will likely be responsible for overseeing the vendor's work also. In modern solution design, there is a component we have no shortage of: servers. The more functionality a software has and the more users there are, the more servers are needed to provide computing power. These servers, including both physical and virtual hardware, and their operating systems, are the responsibility of system administrators. SOC currently lump this job together with network administrators. This isn't as strange as it sounds. In smaller IT shops, we will often find the same person doing both. Only in large organizations will we see them separate into two different people or even two different teams of people. System administrators design, build, maintain, and support servers. This includes all the server hardware, CPU, memory, hard drive, power supply, cabling, and all other back office peripherals. And then on top of that, all applicable operating systems. Just to clarify, by design, we don't mean that system administrators would design the circuitry of a computer like an electrical engineer would. By design build, we mean defining which components to use and assembling them together. Today, even though more and more of these devices are virtualized, the essence of the job remains. We're just seeing less screwdrivers and more point and clicks. Besides assembling parts, a big part of the job is to keep servers up to date with the latest updates, patches, and bug fixes from the hardware and operating system manufacturers. If you think keeping the 2 to 3 home computers in a house up to date is a chore, try managing 100 servers with different hardware and compatibility requirements. One interesting side note: system administrators for IBM mainframe and IBM AS400s are called system programmers. That's an IBM terminology thing that has been used for decades. There is no other official name for it. So if you see a system programmer job posting in an IT shop that uses IBM mainframe or IBM AS400, that's not a programming job. That's a system administrator job. Running on top of the hardware are software. Software can be separated in many different ways. The layer that talks to the hardware directly are the operating systems and the hardware drivers. A special layer that oversees the operations of databases is called database engines. The layers that are used by users are usually referred to as application. They can be further sliced and diced into hundreds of different varieties, such as websites, mobile apps, and things so specialized that it only runs on specific hardwares, like ATMs. But nevertheless, they are software. They are software running on server, laptops, phones, even the cloud. Here, we recognize the occupation software developers. The SOC also recognizes a specialty called web developers. There are many common names for them: programmers, programmer analysts, application developers, software engineers, etc. But independent of what they're called, the essence of the job is the same. Software developers design, build, support, and maintain software applications. The objective is a piece of software that will help users perform their jobs better. Good software developers will balance the user's requirement, the organization's constraints, the performance of the software, and the cost of development and maintenance. If you really think about it, there is no computing hardware that doesn't have corresponding software. Unless we're talking about something that has fixed button controls, like a simple calculator, there's always software serving as the interface between the person who operates the machine and the machine's hardware. In computing, database is in a class itself. Not only does it have its own software category called database engines, it also has specialized personnel overseeing it called database administrators. DBAs install, configure, maintain, and support the database engines. They also build, maintain, and support databases. A DBA might also be assigned the task to perform data reporting, data imports, and data exports. Another common DBA task is to monitor performance and memory and space utilization. Because the database design is usually tied to the software using it, it is usually a collaboration between software developer and database architect. It is rare to see DBAs take on the database design role alone. Information security is not an easy thing. To do it well, it needs to be everywhere. On the perimeter of an organization, there needs to be security devices, monitoring services, threat neutralization procedures, and so on. Within an organization, there are more devices, security zones, security policies, and procedures that mandate different things like logins, password resets, no private cloud usage like Dropbox, and many things of that nature. All that are the responsibilities of information security analysts. Information security analysts design, build, support, and maintain security implement. These implements can be people, process, or technologies. More often than not, they are combinations of those three things. Once implemented, ISAs also monitor activities, raise alerts, respond to incidents, and assist with recovery. In addition, ISAs educate users and executives alike. They also collaborate with security vendors and cooperate with local and federal law enforcement with regard to security events. By now, it should be clear that putting an app together for the bank is a pretty complicated project. The analysts will have to spend many hours over many days meeting with everyone to discuss their needs, constraints, and concerns. They'll have to spend many more days over many more hours meeting with all the stakeholders to get other decisions made, then document and explain them back to everyone. If anyone disagrees, the cycle continues. Then the architects can discuss the preliminary design choices and start looking for new technology components needed. Non-IT personnel, such as procurement and attorneys, will have to get involved because there will be new vendors and new contracts that need to be put in place. Once other choices are made, the architects can put together the final design. Then the software developers, DBAs, system administrators, and network administrators can go to work to build what was designed. Partway through, the testers will start to get involved to make sure everything works as they should. Then the bank personnel need to be trained, the call center will need to be staffed, the new customer service team will need to be trained. When everything's ready, the apps will have to be released to Apple and Google. We didn't even talk about changes in the business processes, such as those related to deposit reconciliation and any number of accountings and audit reports that will be needed. Not to mention other efforts such as marketing commercials, communications needed for the account holders, and work that need to be done on the website to announce this new app. The massive job of coordinating all of these tasks and all of these participants is what we call project management. Naturally, the job falls to the namesake project managers. The occupation is called project management specialists. Even though SOC does not make a distinction between PMs that do IT projects versus PMs that do, say, construction projects, it is commonly accepted that PMs are industry specific. The primary functions of PMs is to ensure everything in the project scope is completed on time and on budget. To do that, PM will manage and manipulate the task sequence, dependencies, allotted time frames, and scheduling. In addition, they're responsible for providing progress reports periodically to project sponsors and executives. With the timeline we just saw, there are a couple of new jobs. The first one is testers. SOC calls it software quality assurance analysts and testers. Testers are responsible for testing whatever being implemented to ensure it is error-free. They create and maintain test plans that has all the test cases, test matrices, and records all the test results. If there are any issues, they raise bug reports so that it can be tracked down and fixed. The next is trainers. SOC classified this into the occupation of training and development specialists. In the job market, they are sometimes called corporate trainers. This is another uncommon IT job. Most of the time, training is viewed as professional development and is the domain of an organization's human resource department. Nevertheless, due to the complexity of some IT solutions and the technology jargons involved, dedicated IT trainers are not unheard of. Trainers' primary functions are to develop and maintain training programs and to conduct them to train current and new personnel. Recall a solution has a time dimension that we labeled birth, life, and death. The next two jobs only shows up in the life stage of a solution. The first one is operators, or computer operators as they are sometimes called. For classification purposes, SOC has dumped this into a catch-all called computer occupations or other. This is an older job. In the past, in order to improve daytime performance, many software applications were split up into two parts. One, an online components that the users interact with, and two, a computing-intensive batch component that does not require users' input. These batch processes were meant to run at night when no user is around. Before automation was reliable, they had to be launched and monitored manually by the operators. Operators' primary function is to launch batch processes, make sure one finishes successfully before starting the next one, until all the batch processes are done for the night. If anything goes wrong, they would escalate to on-call support. In today's 24/7 world with increasingly powerful computers, batch processing is not as common as before, so neither is the computer operator's profession. The second job that only shows up during the life stage of a solution is help desk. The name of the occupation is computer user support specialists. These are the people users call for help. They are trained to triage problem, help if they can, escalate the issue to specialists like programmers or network engineers if they cannot help. We usually see two variants of computer user support specialists. One type sits in a call center and talks to people who need help over the phone, maybe even connect to the caller's computer via remote control software. The second type actually get dispatched physically to visit users who need help. While they can be set up to serve only internal personnel, they can also be trained to support external parties, such as customers. In the example, it is likely that the bank will have two different help desks, one for staff in the bank and one for account holders who have problems with the app. There are many newer IT jobs out there that we didn't really talk about in our example. One group of them often include job titles with these words: business intelligence, business analytics, and data scientists. The jobs are usually an amalgamation of software development, software configuration, database development, data analysis, statistical analysis, and executive reporting. But when you boil it down to its essence, those are essentially specialized software development jobs. Another not very well understood job relates to the field of artificial intelligence. As of this writing, the core of AI exploration is 5% philosophical and 95% software configuration and development. Basically, the work involved coding and configuring learning engines, preparing and feeding learning data into those engines, and evaluating the results with test data. Most of these occupations have multiple levels in correspondence to the expected skill level, experience level, competency level, and how much supervision a worker needs. For example, in the computer system analyst occupation, we will see CSA 1 is an entry level position, CSA 2 for those who has advanced, and senior CSA who is fully capable without any supervision. There are no clear definition of what the levels mean. By and large, government hiring structure usually have more levels, while private sectors usually have less. More technical occupation usually have job ladder that goes up to the corresponding architect levels. But whether the job and job title actually exists for any given company is entirely based on need. I hope this video provides a better sense of what type of IT jobs are out there besides programming. Of course, each of these occupations deserves their own video regarding the details of the job, the qualifications, the professional development paths, and the career paths. Feel free to leave me a comment if you want to see anyone in particular. Thank you for watching.